think we went over this once before, but we're going to circle back around and hit this again. We're looking at concrete. Let me make sure you guys can see it. It's fully fractured with the exception of rebar on the back side of it. So with the exception of reinforcement on the back side of it. The reinforcement is in a format of wire mesh, which you can see there, and the two pieces, one and there, upon the full fracture. And the full fracture. So if you were going to do a repair of a full fracture deck like this, obviously, if it's loaded from this side, it will just open up. So, obviously, if it's loaded from this side, it's pretty heavy. It's about 300 pounds or so, I'm guessing. But obviously, it would open up and wouldn't be able to support anything. The rebar would be in compression on this side, would not help out as the loads went through. So you need reinforcement down here to close this crack up. One of the things they did, they used epoxy on the underside to try to bond the two to create a connection. That's when you see the epoxy added. That is just puts the concrete still in tension. Adding epoxy here doesn't do anything. This is an exaggeration. Adding epoxy there doesn't do anything. Let's see if I can get you over here now. So, as we get closer to the point, this is the shear crack now, right? As it gets closer to here, it looks like it's closed up. It does have a negative load here to help support that cantilever, all this over here. You make sure, yeah, you can see it right here to the edge of the image. And as I load it, you can see that it doesn't open up. The crack is closer to a support at this point. So this crack looks like, oh wow, looks stable. And that's because it's so close to this column and the steel, it can now act on a different capacity. Even though it's at the top, it can act as a different capacity. Now, as I move it further away from its bearing point, it now doesn't perform as well. More of a crack opened up. And as I move further and further towards the center point, that's when it really wants to do that, open up. As I go back towards its shear point again. If I load here, I'm down this side, right? So no big deal. If I step on this side though, now the load's being transferred through this wire, grabbing back here along with the counterweight, if you will. Okay, can't quite see that, can you? Along with the counterweight that's over here. But as you can see, loading in the center is not going to help us, is it? It's going to putting epoxy here would just it's just useless. Now look what's happening also. I'm getting spalling as this cycles, and I've only cycled it a few times, and now she's spalling out. And now she's spalling. The concrete's starting to lose its ability as it spalls like that. Zoom out best I can. Now it's changing its profile of what it can do. It's there and trained. But let's do something here. Let's flip this over and see if we can get this to still work, pretending that this reinforcement is then added to the bottom in some format, meaning that somehow they were able to get reinforcement at the bottom, which would be Not one of the easiest feats. That would be the staple technique that I showed you back here on this one, where I showed you the how you would staple it, basically. How you would staple it. It's a full fracture, if you remember. Full fracture. And maybe we'll show that in just a second. That can be bars. That can be angle iron with post-tension bars between it. A steel bar, a rod between it that you can bolt and turn the tension up to keep it in tension at the bottom. I think you guys should be able to extrapolate by now, watching the channel this long. You should be able to extrapolate this being a thread all. If I were to put a clamp here, a L bracket here and here, and clamp it, but on the other side it would close it up. So let's go ahead and pretend like that's a clamp, that this is the clamp side. And let's go ahead and flip this over. Okay, so now we have our clamp would be right here. This would be the clamping surface, the angle iron and the thread all, if you will, like an external post-tensioning. And give me a second. These are two pieces of steel. They look like that. And that you'd run a thread all through them, a post-tension bar through them, and tighten them on each side. That would go here, mounted here, and thread and tensioned up. So it would be like that. Of course, you don't want it wouldn't bend over. It would be reinforced not to bend over. You'd put them here and here. That would be externally mounting it. Externally mounting it. That would have the same effect, pretty much, of that, except for you'd be able to watch it, monitor it. So now I can load this as much as I want, and all it's going to do is close up here. Won't do. Well, let's see if I can get a little bit more elevation on that to give it more torque. Get these cracks closed up a bit. Okay, it's not quite working out either. There we go. So now when I load here, that's in tension. Right, so now I can load this full crack, and the bottom part is in tension. But this doesn't work. This does not work if this is fractured like this, if it's fully fractured open, because then it changes its load capability right about here if this is fractured open here. So you still need to solid fill this crack here so this performs in compression still. So this stays in compression, the top part. That's the tension side, compression side. It doesn't work if I allow this gap to remain. It will still cycle. You need to close it up. Epoxy is real good at closing that up. Expansion and contraction would be an issue, but epoxy is real good at closing that up. It won't crumble like the concrete if you try to do that. So you would route it and close it up. Route it pretty good. Maybe do it in sections so you don't cause a full failure. You could also do things like craziness, like go through through plates and try to tie this all together where this acts like a truss system. It's pretty sophisticated what I'm talking about there. But that would be external repairs, which I prefer over, because you can monitor it, which I prefer over trying to do drop slabs, which are just the staples. Staples are are nice, right? Hold on. There's our staple. There's our one piece and our second piece. Now, these are still, you know, very poorly, very poor in density as far as you can see, but it still works. Obviously, if I put a load up here, it's going to open down there, right? And obviously, if I put a load in this direction from this side, it's going to open on that side, right? So that's pretty evident. That's pretty obvious stuff there. So, considering I'm going to load it from this side, this will be the loaded side. I take my staple, which you can your staple, as I call it, just for you guys so you can understand it. And you can imagine there's that rebar, has that post-tension bar, etc. A lot of different techniques. And I place it inside there. So then I epoxy that in inside these holes here. Let's see if you can see it. Yeah, so it would be that whole epoxy and epoxy. Now I would still epoxy this. This would still get epoxy, the top seam would still get epoxy in it. So it bonds it and it won't have a cycling issue. You don't want this to cycle. You don't want it to flex and keep loading under your deck cycling. But as you can see, when I rotate this staple over, without crushing my fingers, placing it down. Okay, let me make sure I got that. Well, it took a cycle, didn't it? Placing it down between that span. This is a 1 foot plate, incidentally. Rebar. Make sure you can see it. Okay. So I'll span. Good. So I want to make sure it's off the staple, and I need to span it. So I'll grab a couple of bricks. Yeah, now I put away all the bricks. You believe that? I'll just take it from here on a hill. That's on the staple, of course. And we'll do this. Oh, I'm starting to lose it. It's starting to spall away a bit. Okay. So that staple's in there. The staple is in there, so I would need the epoxy still to make it stable, so the compression stays equal here. My staple is too wide, and so I have an open. It's open here, which is not my intent. This is the clamp. In fact, the thread all would close that up, so it stays taut down at the bottom there. But this, yep, looks pretty stable. This I can step on, even though we know that all it's holding it is the staples. The staple down the bottom is stopping from opening up. And up top here, it's compression up here that's holding this together. And that's why the epoxy would work up top here, a staple down the bottom. So was it ever right to put epoxy at the bottom? Yeah. You know, I don't want to get sued, but I find it not correct to put epoxy at the bottom. There's your opening. So there's your epoxy. Your post-tension bar would be there. I'm going to turn this on the side. Might get little pinch fingers on that action. Okay, so now you can see on its side it doesn't work. I would need another bar stapled in the other direction if it was two directional as far as loading laterally like that also. But loading this way, I'm perfectly okay. As long as, again, I don't twist it. So let me show you a twist. Let me show you a torque. if I were to torque this direction, you can see it doesn't work as well anymore. It could, you know, you've got that going on. But remember, as long as you don't do that, you can load it. You can seriously load it. Okay. So there you have it. So you guys talked about Papa Smurf's clothing. Yeah, I fall on the Papa Smurf myself. I think it's, you know, unless I'm going out, I get dressed up. But otherwise, I don't use clothes to impress anyone, so I don't fall under the halo effect. I know you guys beat his clothing out, but it's you know, he's 80 years old, whatever it might be. Clothing is not really his life concern anymore. Gray sock. Different color gray socks. I've been doing that for years. I grab 2 socks, don't even care. Okay, so doing this mock-up for you. It's cost me a blade, a few other things yet to come. Alright, so what we have here is just some bar cut, because it has directions in 2 holes, making it easy. I can't really thread the nut onto this end. This end is kind of deteriorated, destroyed. So there's this tool you use that looks like that, and without tearing your hand apart, you round off the shape of it a bit. Oops. You round off the shape a bit, and theoretically you're able to thread the nut onto it. I know I'm at the end of the image, so that gives me a little distortion, so bear with me. I didn't cut this rod, someone else did. I cut rod on an angle, I did a video on that. It needs a little more work. Glasses on, just push the limit to it. Looks like it's almost rounding it off too much, but I don't think so. I think it's going to get results we need. Maybe a touch more. Let's see what we have here. It felt good. Felt good for a negative turn, meaning I never made a full turn. Okay. The other way is thread it all the way down, or cut the bar again on an angle. So threading it down would be one way. Of course, you can cut your finger on that. All right, let's try the other. Let's see how lucky we get with the other one. Better yet, let's not. Let's do it. That's a amygdala thing wanted me to thread it all the way down, because it doesn't want to take the L on that, on the L meaning the loss on that. So it'd rather thread it all the way down, which takes more time. See, the threads are quite not there yet. So I'll just grab the saw and I'll cut it on an angle. Is what I tell people to do. We got a piece of steel, hopefully it's not too hot. There we go. It was kind of hot. Cut it on an angle, and you're mostly able to thread it right on, as you can see. Cut your rebar on an angle, not square. You mess up the threads. So that's one. So much for that being any good. Let's see what happens if we tap it a little bit. See if that made it any more smooth, or took off anything, or made it worse. That's a new tool. I would say it kind of made it worse. Felt like it had more trouble with me. Alright, so that's ready to go inside there. I'll put it on the outside here. Thread it on. Same thing with this one. Let's just see how close. I didn't cut this, like I said. You can see how deformed it looks. Let's see. Let's see what this can do first. Maybe it did something. Let's see. Yeah, you know, if I wanted to cross thread it a little bit and dig into the, you know, gall it up a little bit, I would continue with that process. Slight angle. Let me pick that up so my lawnmower doesn't get it. Slight angle, and then thread on. Where are you in the camera? Here we go. As you can see, this is slight angle. All right. So let's put that back in there. I mean, let's put it in here rather. Let's use the outer edges. I'm using the outer edge of this because this bar is very expensive, and normally I would tell you to do the whole length, the whole width, and maybe even further. But let's have a little fun. Let's have a little fun, and let's create it so we don't. If we go too close to the edge with our drilling, all we're going to do is create a cone, a failure, a spalling failure. So we're going to set it back, you know, quite some distance, and we're going to thread. We're going to use this type of bolt because it's so easy to use in this case, and I can pull it in. I can get rid of it. I can take it out. I could use shielded lead, remember, just for this, but otherwise it would be drilled and epoxied. Would be your better choice, and not the lead, and also the shear values of these would matter, and all of this reaction would matter. But we're just showing you concept. I'm showing you concept right now. So this is very powdery concrete, and I'm working my way up to the drill bit size I need. This might be good enough. So I said very powdery concrete. I have a reason why I said that. You know, guys. Remember when they said the concrete was soft when he drilled it? He's using a damn impact drill, a hammer drill. It's going to take the materials and grind them basically down to nothing. You're not going to be pulling out. It's not a core bit. You're not pulling out. Materials, but in whole. But yet you are. I want you to observe the different colorations. So you can see that at one point I hit a stone of this nature, and then I hit mortar and stone, different degrees of mix right there. Well, it looks like that's going to be the anchor I'm going to use. Different degrees of concrete. Alright, so I'm going to have to do this kind of weird. I'm going to have to clean the hole out. I don't want to blow it out. Let's see. Don't want to blow it out, do I? So this is a blower. Whenever I need a quick blow job, I use this tool here. This little bit of what's left behind can actually help anchor this. This is another anchor you can use, a sleeved, where are you? Too zoomed in. A sleeved anchor, and it would work from the bottom side, wedging. This is a helix type anchor. Will it work? I don't know. I get so luck with these anchors. Sometimes they want to just spin and strip. Sometimes they want to act nice. Let's see what we got. This time we have something nice. Look, I can still move it. So now. I can't move it. Well, I can still pivot it. Let's just, now it's spinning. So let's just cut the losses. And let's go ahead and put the next one in. Aware of what's coming out of the hole, and then you know I'm hitting stone, I'm hitting mortar, etc. So right now it looks like this. I hit a different stone because that's no longer white. Let's do that. Let's start from a little bit of scratch. Let me watch. You see that color? And then you see the other color that popped up. So, interesting little deal, isn't it? Over here. Yep. So these cones are too close to each other. In other words, if I had a pull-out test for this, one would probably fracture the other one. But in this case, I just needed to take a little bit of loading to work for me. So let's see how we work here. That's snug. That's snug. This one's got to come out. Let's zoom out. Zoom out. Hold on. There we go. Let's pull this one out so we can get that one down further. They only got so many cycles in them. You're not going to keep cycling these things forever. That might be enough. There's a little mortar in there in that one. So it might help bind because it was kind of loose. So I might put a little bit back in there, just to help me get some grip. Let's put that back in there. Now these cones will miss each other. Let's go ahead and anchor that. Nice and snug. See it spinning? It's spinning. So that means I lost my grip force. But we'll still be able to serve our purpose. Now, as you recall, let's see if I can do this right now. Yep. If I flip this over, it's going to come apart. So let's do that. Let's flip this over. And make sure that's loose. Alright, so it's pretty loose. I need a, looks like 14 millimeter. Yep. And then maybe a box end on the other end. Thought I had my box end with me. Open, adjustable. So, looks like we're going to settle for, what we can. Alright, so when I turn this over, we're going to see it open up. Alright, so let's open it up. And let's see, I want to turn your direction. So you clearly see it's opened up. Right, so you can clearly see that. And we can see we're no longer, the plane is off the top too. Let's get the plane back, a little more alignment. Now that plane's pretty good actually. Now, if I were to load this, obviously it's going to open up. The tension goes into this bar. Let's go ahead and zoom out a little bit so I can get you both at the same time. There we go. So now let's go ahead and tighten this up. Where'd you go? Where'd you go? Oh shit. I got the half-inch, the wrong driver. I have an adapter though, give me a second. Oh well. I got all types of tools, but not the adapter with me right here. Oh, this might be 14. Let's get these in alignment. Let's get them in alignment. I don't want them crushing like that. Oops. Lost a nut. Hopefully you guys can see it. Let me see. Yeah, you can. So let me get this torqued over a little bit like that. See? Maybe I'll put a chrome underneath there. There we go. Now I'll tighten it up. You see that? And here's this one. So now the tension, and it's really on that bar. This bar is crowned. Each one is crowned. We want to get them the tension equally. Great. I'll just throw that there too. But remember that this is the side that opened up once I loaded it from this side. But now look, watch what happens when I back the camera up and I load it. So this would be this angle. Let's see. Zoom out. Looks like I'm zoomed out as much as I'm going to get. I got to back up. Okay. So now we'll put it between the center line of here where it had issues. And make sure I don't get pinched. So center line of my span. Rotate over. Now I load it. And even though that rebar's up top, you see now it's closed because we made that clamp. That's another version of the staple, if you will, but that one's an external. That would be external, and you see how beautiful that is. It's external and it's beautiful. Let's try something else. So now I know you got to put up with the noise, but now I'm going to point load it with the weight of the machine. I'm going to lift the machine off the ground. Off the ground. You're going to have to see that raise up to understand it's off the ground. You're going to keep an eye on the fraction. There we go. Onto a hammer so you can get it even more point loaded, but I'm going to just use the teeth for a bucket. I use a larger hammer that distributes the load a little bit more, but it's still across the fracture that was fully through. Remember, it would open up. me just beat that up just now. That was definitely off the ground. Let me get you up, let me get you on a handheld. So that was just with, and we're not even in my zone anymore. It's transferring. We're way out here on the outer edge. We're on the outer edge. We're not where you saw me put the clamps, which is more in the middle. That's where the epoxy would help fill it in and how that would help work. And that is the piece. So you guys know that is the clamp. There's the clamp. And it's under tension. Alright, hopefully this was helpful, especially new contractors out there and other engineers that might want to consider external clamping. And you can load test it, you can look for deflection, which is something that you can find immediate value in without worrying about it. You know, you can look at it over time, you can look for rusting, you can add more of these clamps. Let me shut this down a little bit. You can add more of these clamps as you go. Let's see if we can bring this down. So you can add more of these clamps as you go. You say that those clamps will start looking a little funny over time. Well, there's nothing that says you can't. Okay. Nothing says you can't just add more of these. I'm gonna flip this over. That you can't add more going through, bypassing, going around it even. So in other words, larger clamps back here. You can step it, so you have some redundancy. Primary, secondary. You'll be able to observe cracking if you do it something like this. You'll be able to observe and monitor. You can find torque inside this if you need a crush plate in here, obviously, and you need real post tension bars, not what I just did there. But you can see how it's still, even though I just flipped it over, how the compression is still in there. How it didn't, that cycle didn't open it up. I mean, that thing is tight. That is tight. So I just wanted to let you guys explore your brain, you engineers out there, etc., on how you can go about this differently. You can go about it differently. This will be engineered, of course. Post tension bars, clamping, redundancy. Not just one and go, that's it. Add the freaking redundancy. Add the other bars beyond this one. Not just through it, because if this fails somehow, it might want to cut your bar. Have it on the outside of it. Redundancy, another track. So this would be a primary, and then your secondary would be there to help transfer the loads also. This is beautiful. This is what I envision when I see external post-tensioning on these structures like this. And this will be a mid-span, not near the edge. That's another deal altogether we'd have to deal with. But this covers that deflection in the middle. All right, hopefully this helps you guys. Let me shut down this video and grab my tools and put them away because it's drizzling already.